Hello, everybody, and welcome to our latest episode of Tech Bites, bite-sized tech talks for teens. My name is Andrew. I'm the co-founder of HighTechU, and I am so thrilled to be here, not to talk to you, but actually to introduce one of the amazing staff of HighTechU, Venish, Patel, who's going to be doing our tech talk today. So if this is your first time ever visiting a HighTechU tech talk here on Twitch, I'll just give you a little bit of an intro, but if you're not quite sure the session that you've stepped into, you are here for Tinker's introduction to Arduino. This tech talk is presented by the University of Victoria Department of Electrical and Computer Engineering, and it's great because this also feeds into our amazing summer program that we're going to be offering this summer for the first time ever, our virtual summer camp, our virtual skills academy program that's going to be taking place the first week of July. Applications are open until mid-June, so you can head over to hightechu.ca/apply if you're interested in finding out more, and also hopefully today's session will give you a little bit of an introduction into what that's all about. So with all that said, today's session is as interactive as we can possibly make it. So we have our stream chat that's available to you as a user. So you're welcome to put in your comments or questions you have for Venish as he's going along, and he'll do his best to answer them. And aside from that, I think we're just about ready to get started. Just a note for everybody, I did update the tweet on Twitter. But if you are tuning into this, obviously we are on the Pacific time zone, so we are here in it's 4 o'clock, and we're just getting started today. So with all that said, I'm going to turn the show over to my good friend Venish, who's gonna jump on to the Zoom call now. How is it going, Venish?
Yeah, I'm fine, Andrew. Good to go.
Awesome. All right, so Vanish, I'm going to turn the show over to you, and I'm here to support you, and I'll pass over any questions that any of the viewers have.
Hello, folks. I'm Venish Patel, first-year graduate student from University of Victoria, pursuing Master of Engineering in Applied Data Science. In today's session, I will give you overview about my favorite microcontroller, which is an Arduino. Microcontrollers are integrated circuits that are basically tiny computers. They can run small software programs. They are low powered enough that they can be powered by a battery for days, but they are fast enough to process data much faster than any human being can think. Arduino is a company in Italy that designs and sells circuit boards that make microcontrollers easy to use. There are a lot of different types of Arduinos. For an instance, we have simple Arduinos, which is cheap and good enough for most projects. You could use an Arduino Uno to control motors, lighting, camera, or even build a simple robot. And then we have more fancy Arduinos with more powerful processors, which also have Wi-Fi, Ethernet, and more. The company Arduino open sources all of their hardware designs, which means that you don't just have to buy from them, you can also make their own. There's also the Arduino software development environment, and this is what makes Arduino good for beginners. Historically, if you wanted to program microcontrollers, you'd have to type a lot of binary and memorize a lot of hard to remember register and instructions. Then you'd also have to use special programming hardware. Arduino, the company got rid of all that. They created software that works on Windows, Mac, and Linux, which makes uploading your code as simple as connecting a USB cable and clicking a button. They created a programming language that lets you configure all of your Arduino hardware. In the same way, the Arduino software is one of the easiest programming to learn. Hopefully, that clarified what Arduino means in different contexts. In this session, we'll talk about what's on it and what it can do. These are the major components of the Arduino Uno board: USB connector, power port, microcontroller, analog input pins, digital pins, reset switch, crystal oscillator, USB interface chip, and TX RX LEDs. The first component is the USB connector. This is a printed USB port used to load a program from the Arduino IDE onto the Arduino board. The board can also be powered through this port. The next component is the power port. The Arduino board can be powered through a AC to DC adapter or a battery. The power source can be connected by plugging in a 2.1 mm center positive plug into the power jack of the board. The Arduino Uno board operates at a voltage of 5 volts, but it can withstand a maximum voltage of 20 volts. If the board is supplied with a higher voltage, there is a voltage regulator. It sits between the power port and the USB connector that protects the board from the burning out. Now, let us take a look at very important component, which is microcontroller. It is the most prominently visible black rectangular chip with 28 pins. Think of it as the brain of your Arduino. The microcontroller used on the Uno board is Atmega 328P by Atmel. Atmega 328P has the following components in it: flash memory of 32 KB, the program loaded from the Arduino IDE is stored here. RAM of 2 KB, this is runtime memory. CPU, it controls everything that goes on within the device. It fetches the program instructions from the flash memory and runs it with the help of RAM. Electrically erasable programmable read-only memory, EEPROM of 1 KB. This is a type of non-volatile memory and it keeps the data even after the restart and reset. Atmega 328P is pre-programmed with bootloader. It allows you to directly upload a new Arduino program into the device without using any external hardware programmer, making the Arduino Uno board easy to use. Next is analog input pins. The Arduino Uno board has 6 analog input pins labeled analog 0 to 5. These pins can read the signal from an analog sensor such as temperature sensor and convert it into a digital value for system understanding. These pins just measure voltage and not the current because they have very high internal resistance. Hence, only a small amount of current flows through these pins. Although these pins are labeled analog and are analog input by default, these pins can also be used for digital input or output. Now let us look at digital pins. You can find these pins labeled digital 0 to 13. These pins can be used as either input or output pins. When used as output, these pins act as a power supply source for the components connected to it. And when used as input pins, they read the signals from the component connected to them. When digital pins are used as output pins, they supply 40 milliamperes of current at 5 volts, which is more than enough to light a LED. Some of the digital pins are labeled with tiled symbol next to the pin numbers. Pin numbers 3, 5, 6, 9, 10, and 11. This pins acts as a normal digital pins, but can also be used for pulse width modulation, which stimulates analog outputs such as fading an LED in and out. Next component is reset switch. When this switch is clicked, it sends a logical pulse to the reset pin of the microcontroller and now runs the program again from the start. This can be very useful if your code doesn't repeat and you want to taste it multiple times. Next is the crystal oscillator. This is a quartz crystal oscillator which takes 16 million times a second. On each take, the microcontroller performs one operation, for example, addition, subtraction, etc. Now we'll look at the USB interface chip. Think of this as a signal translator. It converts signals in the USB level to a level that an Arduino Uno board understands. The last one is the TX RX indicator. TX stands for transmitter and RX stands for receiver. These are indicator LEDs which blink whenever the Uno board is transmitting or receiving data. Now that you have explored the Arduino Uno board, you have started your journey towards building your first Internet of Things IoT prototype. This is a full view of Arduino Uno board, how different component works and how different components are assembled into this system is displayed in this image. There are a few real-world innovative usage of Arduino Uno. The first one is plant watering system. Using this Arduino system, you can water your plant every day without forgetting. You can also play tic-tac-toe game. There's also a buzzer alarm system for your house security. There's also a thermometer and a fingerprint sensor. This all are the real world examples of Arduino Uno, and they are really good to start learning Arduino Uno. Thank you guys.
Awesome. Thank you so much, Venish. I'm just gonna jump off of your screen share right now. Just give me 1 second, folks. I'm gonna do my side-by-side mode and then jump back over to me. Speaker view. There we go. And it's not letting me have as much. Oh, there we go. That's what I'm looking for. So give me 1 second and I'll get all this sorted out for us, because we're obviously having a couple of technical difficulties here. Just give it 1 second. All right, and back over there. Perfect. So again, thanks so much to everybody that was able to come. Thank you so much to Venish for that great sort of really awesome tinkerer's introduction to Arduino, and particularly talking about the Arduino Uno board. This is the first part in a four Wednesday series, so a 4-week series that we're doing on these amazing electrical and computer engineering concepts. So please tune in the same time, 4 o'clock next Wednesday, for the next in sort of the series of showing you not only what Arduino Uno is all about, but how you can then start to build with these kind of amazing platforms that exist. So just before we head over, again, today's episode, Tinkerer's Introduction to Arduino, was brought to you by the University of Victoria Department of Electrical and Computer Engineering. HighTechU, or Tech Bytes, is an initiative of HighTechU, which is a initiative of the University of Victoria Faculty of Engineering, and we're so grateful to not only the Faculty of Engineering, the Department of Electrical and Computer Engineering, and to our amazing sponsors and funders such as Coast Capital Savings and our other amazing funders that help to make HighTechU available and free. If you're interested in checking out any more of these Tech Bytes sessions, please head over to our website at hightechu.ca/techbytes, where you can check out all of our episodes. You can also, of course, catch all of these episodes on our YouTube channel, which is alas not youtube.com/hightechu, but if you search HighTechU or you follow the link on the website, you'll be able to check that out. And of course, we have another amazing tech talk happening tomorrow here on Twitch. That's going to be with our friends from Story Studio, and they're doing an amazing talk on storytelling in the technology and engineering and science industries. So from all of us here at HighTechU, thank you so much for attending today's live stream. We're so thrilled to have you as part of our community. Stay safe, stay healthy, and looking forward to seeing you at our next episode. Bye-bye.